Lesson 8.5, simplifying radical expressions. So we're going to use what we did in the last unit or the last lesson and expound on that, go further into it. So a radical expression is an expression that contains a radical, such as a square root. It does not have to be a square root. Now, a square root of a number is a value that when multiplied by itself gives that number. So a square is 2 times 2, and that's 4. But if I took the square root of that number, it would be 2. Okay? Perfect squares. 4, 9, 16, 25, 36, 49, 64, 81, 100, blah, blah, blah. Okay? Principal, square root is the positive solution. Okay. So basically what we're going to be doing is, if I told you to take the square root of this, you can split it into 2 because there's multiplication going on, and take the square root of each part of that. Okay? Same thing as if you have division. I can take the square root of the top part. I can take the square root of the bottom part, but I could also simplify the fraction first. 100 divided by 4 is 25. So you can do that either way. So a square root in the simplest form, if these conditions are true, the square root contains no perfect square factor other than 1. The square root contains no fractions, and there are no square roots in the denominator. Okay? So if I look at this, 72. So personally, when I do this, I like to go for perfect squares. So I look for a perfect square first. So in my brain, I say, does 4 go into that number? So 72 divided by 4. That would get me 18. Oops, Kimberly. 4 times 18. Okay, so then I look at 18 and I'm like, what perfect square goes into that? 9 does, times 2. So if I was to rewrite this, this would be 4 times 9 times 2. I can take the square root of 4 times the square root of 9 times the square root of 2. This is going to get me 2. This is going to get me 3. And I cannot take the square root of 2, so I leave it as is. So 6 square root 2, or 6 radical 2. And that is my answer. Okay? So let's come over here. I look for a perfect square. 4 goes into this number 6 times. There are no perfect squares that go into 6. So I have 4 times 6, square root of 4 times the square root of 6. That will get me 2 radical 6. Over here, does 4 go into 108? It does, 27 times. What perfect square goes into 27? Well, 4 doesn't go into it because 27 is an odd number, but 9 goes into it 3 times. So if I was to rewrite this, I have 4 times 9 times 3. The square root of 4 times the square root of 9 times the square root of 3. So 2 times 3 times the square root of 3. So 6 radical 3. 50. Well, 4 does not go into 50. 9 does not go into 50. 16 does not go into 50. But guess what? 25 does. And it goes in 2 times. So if I was to rewrite that, that would be 25 times 2. The square root of 25 times the square root of 2 will get you 5 radical 2. Okay. Next part, multiplying square roots. Okay. So basically what we're doing is we're taking 5 times 48. Now I'm not going to actually multiply 5 times 48 right now because I'm trying to simplify this. Okay? So I want to multiply it, but yet I also need to simplify this. So I'm going to take 48 and 4 goes into that 12 times. 4 goes into that 3 times. So if I was to write this, the square root of, I have 5 times 4 times 4 times 3. These two are perfect squares. So I'm going to do the square root of 4 times the square root of 4, or you could have done, multiply those back together and gotten 16. And then I'm going to leave these two that I can't take the square root of underneath the radical symbol and multiply them together. So I'm going to get 2 times 2, so 4 radical 15. Now personally, I know that for 48, oops, I meant to do that. Oh, jeez Louise. I meant to do this. I mean, I know in my brain that this is 16 times 3. So I would have done it that way, but does it matter? No, because you get the same answer. So this one, I have 7 times 14. Well, guys, if I look at this, I have 7 times 7 times 2, because isn't 14 2 times 7? Now, did I actually want to multiply that out? No. But 7 is not a perfect square, 7 is not a perfect square, 2 is not a perfect square. But this right here, isn't that 49 times 2? So the square root of 49 times the square root of 2. So that would be 7 radical 2. You could have also done it this way. You could have also done 7 squared times 2. The square root of 7 squared times the square root of 2, 7 radical 2. Either way, you still get the same exact answer. Okay, this one. 8 times 14. Okay, so I know that this goes down to 2 times 4. This goes down to 2 times 7. So why didn't I take this one down further? I can. Maybe this time I will. I'll take it down further. So I have, how many 2's do I have? I have 1, 2, 3, 4. I have 2 to the 4th power times 7. Okay, so the square root of 2 to the 4th times the square root of 7. Remember, in the last chapter, we learned that square root means half, right? So we're going to take half of that exponent, which is 2. So the answer to this is 4 radical 7. Okay, last but certainly not least of this, I'm going to multiply this, 15 times 3. 15 is the same thing as 3 times 5. So I have 3 squared times 5. The square root of 3 squared times the square root of 5. This gets me 3 radical 5. Okay. Divide square roots. Okay, I'm going to tell you first, simplify the fraction first. What goes into both of them? 3 goes into both of them. It goes in 8 times here. It goes in 9 times here. Okay? So, I'm going to do it off to the side. 8 is 2 times 4. So I'm going to do, and on bottom, the square root of 9 is 3 times 3. Okay, so if I do this, I get on the top, that's the square root of 4 times the square root of 2 over the square root of 9. So 2 radical 2 over 3. Okay, so the next one. Well, 63. 5 doesn't go into that, so there's no way to simplify that. So I look at 63. That is 9 times 7. So I have the square root of 9 times 7 over the square root of 25. Square root of 9 is 3. You can't take the square root of 7 over 5. Okay, this next one. Oh, I can simplify that. 3 goes into both of these. So I get 25 over 4. So the square root of 25 is 5. The square root of 4 is 2. Five doesn't go into either one of them. 35, there's no perfect square that goes into 35, so we just leave it as is. 28, though, that's 4 times 7. So 4 times 7. Oh, back up. I can simplify this fraction. Look at that, boys and girls. I did not pay attention. 7 goes into both of these numbers. So I get the square root of 5 over the square root of 4. I cannot do anything with the numerator, so I leave it alone. The square root of 4 is 2. Okay. Now, this time we have variables involved. Okay? The numbers, we deal with them exactly the same. I'm going to come over here. If I have x squared, and I'm taking the square root of that. Remember, square root is the same thing as taking the 1/2. So half of 2 is 1. If I had it to the 3rd power, okay, and I'm taking the square root, this is the same thing as saying x squared times x. So if I was going to take the square root of this part, I take this times this. So the square root of x squared is x. Okay? So you are taking half of the exponent. Well, half of the exponent, well, some of them are odd numbers. So we're going to have to split those apart. I'm going to go ahead and split them apart first. Okay, so all I did was split them apart. Now we have to deal with the 525 now. 525. Well, we know that 25 goes into it. How do I know? Because it ends in 25. So that goes in 21 times. Well, 21 is just 3 times 7. There's no perfect square that goes into that. So this is going to be 25 times 21, x to the 4th, y to the 4th times y, z to the 4th times z. Now, all the things that I can take a square root of, I can take the square root of 25, I can take the square root of this, and this, and this. The things I cannot take the square root of are the things that don't have a perfect square. So I'm going to write this, all the things I can take the square root of over here. And I'm going to multiply that by what I can't take the square root of. Okay, this part doesn't change. On the other hand, this part, well, what's the square root of 25? 5. What's the square root of x to the 4th? Remember, x to the 4th raised to the 1/2. So half of 4 is 2, so x squared. Y squared. Z squared. All you're doing is taking half of that exponent. Okay, so let's come over here. Let's do the same thing we just did. 147 x squared times x to the 4th. That's an even number already. We don't need to do anything. Z to the 4th and z. Well, now we have to figure out 147. Well, 2 doesn't go into that. 3. Well, 1 plus 4 is 5. 5 plus 7 is 12. So 147 divided by 3, that will be 49. Okay, so if I rewrite this, I now have 3 times 49 times x squared times x times y to the 4th times z to the 4th times z. I'm going to separate it. I can take the square root of 49, x squared, y to the 4th, and z to the 4th. The things I cannot take the square root of: 3, x, and z. So 3x and z are going to stay right where they are. I'm going to take the square root of 49, which is 7. X squared, you take half of the exponent, you get 1. Half of the exponent, you get 2. Half of the exponent, you get 2. Now, if I was just to look from the very beginning, do you see how this is an odd exponent and this is an odd exponent? Do you notice how both of those are down here in the answer? Okay, so let's look at this next question. Okay, look at this. Odd. So that means automatically, boys and girls, that at the end, I'm going to have an x and I'm going to have a z in my answer. I don't know what the rest of the problem is going to be, but I know for sure that I'm going to have an x and a z underneath the radical symbol. So let's look at this. So now I have 48, and I'm going to go ahead, 48, 4 goes into that, 1, 2, 4 goes into that 3 times. Oh, look at that, 4 squared times 3, x to the 6th times x, because remember, you have to get an even exponent, y to the 6th, z to the 8th times z. So the things that I can take the square root of: 4 squared I can take the square root of, x to the 6th, y to the 6th, and z to the 8th. The things I cannot take the square root of are 3, x, and z. Look at that, x and z. Also can't take the square root of the 3. Now, we just divide all the exponents in half. So 4 to the 1st power, x to the 3rd power, y to the 3rd power, z to the 4th power. Okay. Now, This time, if it's a cubed root, that means, trying to give myself room, it's going to look like this, or something raised to the 1/3 power. So we need 3, okay, perfect cubes. So 8, 27, 64, 125, yeah, blah, blah, blah. Okay, so this time we're going to be finding the perfect cubes of things. Or not the perfect cubes, the cubed roots. So let's do this. I'm not going to go through all of those things. So, what goes into 343? Well, 343, 2 doesn't go in. Does 3 go in? Well, 3 plus 4 is 7. 7 plus 3 is 10. So nope, it's not 3. Does 4 go in? No. Does 5? No, because it doesn't end in 5 or 0. 6 doesn't because it's not even. 7. Well, let's try 7. Does 7 go in? 7 goes in 49. So this is 7, 7. So this is 7 to the 3rd power raised, or sorry, the cube root of 7 to the 3rd power. So that's the same thing as 7 to the 3rd power. I did not mean to do that. To the 1/3. So remember that gets me 7 to the 1st power, which is just plain old 7. Okay, let's do it here. 5 goes in. 5 goes in 27 times. This is 3 times 9. This is 3 times 3. So I have the cubed root of 5 times 3 to the 3rd. 3 to the 3rd, I'm going to take the cubed root of that times the cubed root of 5. So this is 3 times the cubed root of 5. Now, guys, could I have stopped right here? I could have, because 5 times 27, and I was taking the cubed root of that, the cubed root of 27 times the cubed root of 5, 3 times the cubed root of 5. We could have done it from right there also. Okay, so let's look at 40. Okay. Oh. I know 4 goes in 10 times. That's 2, 2, 5. Okay, so 2 to the 3rd power times 5. We're taking the cubed root. The cubed root of 2 to the 3rd times the cubed root of 5 will get me 2 times the cubed root of 5. Now, again, could I have done it differently? Yes. I know that 8 is the same thing as a perfect cubed. Could I have done the cubed root of 8 times 5 and just done 2 cubed root of 5? Heck yeah. But does it matter? No. This one? Okay, so does 8 go into 54? No. Does, okay, 2, 3, does 27 go in? Yeah. 27 is a perfect cube times 2. So that would be 3, the 3rd root of 2. Now, if you want to do it the longer way, which is perfectly fine, I know 2 goes into that 27, 3 goes into that 9, 3, 3. So if I had the cubed root of 2 times 3 to the 3rd, guys, you're still going to end up with the same answer. It doesn't matter which of the two ways you do it. Okay? Okay. This one, we're multiplying or we're dividing, depending on which one. Okay, cubed root. Again, I don't want to actually move these, or whatever I want to say, multiply them. Okay, this is 6 times 6. This gets me 2, 3, 2, 3. So I have 2. I have 1, 2, 2, 3. I have 3 2s and I have 2 3s. I need 3 of these, right? So this is the cubed root of 2 to the third times the cubed root. And since this doesn't say 3 or a number, a fact or a multiple of 3, I'm just going to write that as 9. So that's 2 cubed root 9. Here. We'll do this. 3 times 5, 75. 3 times 25, 5, 5. So I have a 3, I have a 5, I have a 5. I'm going to write it all out for you to help you. 3 squared, 5 to the third. Look at that. Cubed root of 5 to the third times the cubed root of 9. So 5 cubed root 9. Okay, and this one, 2 doesn't go in. Does 3 go in? 375 divided by 3. Yep, 3 goes into both of these. So 168 divided by 3 is going to get me 56. 375 divided by 3 is going to get me 125. Take the cubed root. Guys, this is a perfect cube down here. So 56, 8 goes into that 7 times. So we have the cubed root of 8 times 7 over the cubed root of 125. The cubed root of 8 is 2. You can't take the cubed root of 7. And then the cubed root of 125 is 5. Okay. This next part, forget it. Okay, so remember x to the third raised to the 1/3. That's going to get me x. If it's x to the 6th raised to the 1/3, that's going to get me x squared. So we need the x's. We need the x's to be divisible by 3. But here we can simplify our fraction first. Okay, so let's simplify our fraction first. So 15, 3 goes into 15 5 times. 3 goes into 81 27 times. There are 5 x's here. There are 2 x's here. So there are, okay, and then y to the third, z. Oh, that says to the 4th. So I want to make it z to the 3rd and z. Okay, so now let's take the cubed roots. Okay, we cannot take the cubed root of some of these things. So let's go on top. The cubed root of what I can take the cubed root of. Y to the 3rd, z to the 3rd. What I can't take the cubed root of. 5 and z. Okay, and the denominator. Jeez Louise. What I can take the cubed root of. 27 and x to the 3rd. So if I look up top, I get yz, and then I can't take the cubed root of 5z, so I leave it where it is. And the denominator, 3x. Okay, let's look at this one. First things first, I simplify what I can simplify. 264 divided by 3, does it go in evenly? It does. 88. This right here cancels totally out. This will get me x to the third on bottom because I have 1x on top. I have 4 on bottom, so that cancels out. And then I have y to the fourth on top. So 88, that's 8 times 11, and 8 is a perfect cube. So 8 times 11, y to the 3 times y over x to the third, and the cubed root of that. Okay, so here we go. The cubed root of 8 is 2. We cannot take the cubed root of 11, so we write it over here. The cubed root of y to the third is y. We can't take the cubed root of just plain old y over x. Why does this not want to work? Okay. Oh, I forgot to do this one over here. I apologize. I know 2 goes into both of them. 648 divided by 2. So that's 324. 750 divided by 2 gets 375. Divide that by 3. If I divide by 3, 1, 0, 8. There we go. Okay, so 108. Does 27 go into 108? Yeah, 4 times. 27 times 4. Okay, so this is the cubed root of 27 times 4 over 125, because 125 is a perfect cube. So on top, I get 3. I get the third root of 4 over 5.